So in this question we read here, the angles of elevation to the top of a mountain are measured from two beacons, A and B, at C here. If the beacons are 1,473 meters apart, so that's going to be this distance right here, so 1,473 meters apart. Sorry, that 7's not coming through, good. How high is the mountain? Well, the first thing I want to look at here is the triangle that I've got the most information about, and that's the triangle ABT, which is going to look something like this. So this is 1473. This angle here is 29.7 degrees. Now, I know that this angle out here is 41.2 degrees. Now, together with this angle, that's going to be 180 degrees. So 180 degrees minus 41.2 will get me that blue angle in there, and that's going to be 138.8 degrees as an angle there. Now, the last angle up here is going to be 180 minus those two, minus the 138.8 minus the 29.7. So 180 minus the 138.8 minus the 29.7, and that is going to get me way up here an 11.5 degree angle. Now, the reason why that's important, that's necessary here, is because it allows me to use the sine law, because now I have the side and the angle opposite it. So now I can use the sine law. And what I'm probably going to do is find this side right here, side BT. Okay, and in fact, let's just call that X for right now. So in this other diagram here, that is going to be this angle here, X. I'm going to just get rid of this to clean it up. So I have got 1473 over the sine of 11.5 degrees is going to equal X over the sine of 29.7. And so after I move things around, X is going to equal 147, I keep trying to put that 3 first, 73, times the sine of 29.7, all over the sine of 11.5. That's going to give me X. So I'll do this on my calculator, 143 sine of 29.7 divided by the sine of 11.5. And I'm going to get that X is roughly 3,660.6 meters. Okay? But now that doesn't give me how high the cliff is. Let's call that Y. So in this new triangle BTN, I now know the hypotenuse, and I have that angle at the bottom there, the 41.2. So I'm just going to use the sine ratio. The sine of 41.2 degrees is going to equal Y over X, which I've determined to be 3,660.6. Now, the decimal goes a little bit longer than that, and I'm going to use the whole decimal when I plug it into my calculator. So I'm going to multiply up through that, and I'll get Y equals 3,660.6 times the sine of 41.2 degrees. So my calculator, using that answer that I just created, I'll just go multiplied by the sine of 41.2, and I get that the height of the cliff to the nearest tenth will be 2,411.2 meters, approximately.